Hi everyone, in this video we're going to be doing A-level maths, A-level for the maths 9231 paper 31 for the mechanics major in 2025. This paper is 1 hour 30 minutes long, so we'll try to finish within the time limit. So without further ado, let's get started. Okay, so for the first question, we're told that the particle P of mass 8 kg is moving in a straight horizontal line, and at time t seconds P has displacement x from a fixed point O on the line and velocity v meters per second. The only horizontal force acting on P is magnitude, this newtons, and x in the direction OP. So it is acting away from O. So the force is acting in the direction that P is moving. And we're also told that when t equals to 0, x equals to 0, and b equals to 1. Okay, so for the first part, we have to find an expression for v in terms of x, giving your answer in this form v equals to ax squared plus b, where m are constants to be determined. Okay, so first of all, we're going to use Newton's second law, F equals ma. So our F here would just be the horizontal force acting, x cubed plus 4x, and then m is 8. And acceleration, we can use this relationship of acceleration equals to v dv dx, because v is equals to dx dt. So when you multiply by dv dx, you'll get dv dt, which is also equals to acceleration. So let's use that. Okay, so as you can see here, we have obtained the differential equation. Now we're just going to separate the x variables on the left side and the v variables on the right side. So we just have to multiply by dx on both sides. So we get x cubed plus 4x dx equals to 8v dv. So now let's integrate both sides. Okay, so left hand side, very simple. It's x to the power 4, because 3 plus 1 is 4, and then divide by the new power, saying 4x, that's 4x to the power of 2 divided by 2 plus c. And then 8v dv, that is 8v squared over 2. And the plus c we just have to put on either one side. Okay, now let's simplify this further. So x to the power 4 divided by 4 plus 2x squared plus c equals to 4v squared. Okay, now let's substitute our initial conditions. V equals to 1 and x equals to 0. Yeah, so this would give us the 0x for that 0x squared also 0, so we just get c equals to 4v squared, which is 4 times 1 squared, which is 4. Hence, we get x to the power 4 divided by 4 plus 2x squared plus 4 equals to 4v squared. Okay, now we have to make v the subject of the equation, so let's divide everything by 4. Like on both sides of the equation, so we get v squared equals to x to the power 4 over 16 plus x squared divided by 2 plus 1. Yeah, alright, so let's try to make this as the form a plus b squared. Okay, so when we expand a plus b squared, we get a squared plus 2ab plus b squared. So let's try to figure out which one are a squared and which ones are b squared. So I think this is our a squared. We can rewrite this as x squared divided by 4 whole thing squared, and then this is our 2 times a, and then b will obviously be 1, and then this is plus 1 squared. So now it's in the form a squared plus 2ab plus b squared. We can rewrite this as x squared divided by 4 plus 1 squared, and then taking the square root of both sides, we get our final answer, b equals to x squared divided by 4 plus 1. So this is our final answer for the first part. Let's head on to the next part. Okay, so for this part, we just have to find an expression for x in terms of t. Okay, so we have to make x the subject, and the equation should be in terms of t. Alright, so to do that, let's take our original equation using f equals ma. Okay, so f is x cubed plus 4x. Okay, and then m is 8, and then a we can just directly write as dv dt. Okay, wait. Oh wait, never mind. Let me think. Yeah, I just realized we can use our previous equation found in the previous part. So v we can equate it to dx dt. So this would now be dx over dt equals to x squared divided by 4 plus 1. Okay, so now to make separation of variables easier, let's make this into a fraction. So this is 4x squared plus 4. Okay, so let's divide both sides by x squared plus 4. This would be 1 over x squared plus 4 dx, and then multiply both sides by dt, you get 1 over 4 dt. So now let's integrate both sides with respect to that. So the first one, 4 is just 2 squared, so we have 1 over x squared plus 2 squared, and you integrate this, you would get 1 half tangent inverse x divided by 2. So this is half tangent inverse x over 2. And if you can remember, this result is also given in your MF19. Okay, and then this one is just 1 over 4t. Okay, let's use our initial conditions. So x equals to 0, t equals to 0. So we get tangent inverse 0 divided by 2, which is 0. So you get c equals to 1 over 4 times 0, which equals to 0. So hence we get half tangent inverse x over 2 equals to 1 over 4t. And then, okay, we multiply by 2 and take the tangent on both sides at the same time. So x over 2 is just tangent half t, and then x is just 2 tangent half t. So this is the final answer for this part as well as the entire question. Let's move on to the next question. Okay, so for the second question, we're told the particle P is projected with speed 24 meters at an angle theta above the horizontal from point O on the horizontal plane and moves freely under gravity. And after that, at a horizontal distance 35 meters from O, there is a vertical wall of height 10 meters, which is perpendicular to the vertical plane of motion of P. So for this first part, we have to determine the two values of theta for which P just clears the wall. Okay, so first let's draw the trajectory of the particle P as well as the wall. So let's sketch. So it's moving freely under gravity, hence the particle P is obviously experiencing projectile motion. Okay, so yeah, so let the wall be here. So this wall is 10 meters tall. Okay, and it is 35 meters away from O. And then this initial velocity, it's theta degrees from the horizontal and 24 meters per second. So this is all the info we have. Okay, all right. So in order to do this, we can just use the formula directly, the equation of the trajectory given in your MF19. So for the mechanics, we've got this function formula here. So y is your vertical displacement, vertical, and then x is your horizontal displacement, and then v is your initial velocity or speed. Okay, so let's copy down this formula. So y equals to x tangent theta minus gx squared over 2. Okay, so v squared is going to write u squared cosine square theta. Yeah. Okay, so we're going to substitute x equals to 35 and y equals to 10. Okay, so we'll get 35 tangent theta minus g, that's 10, times 35 squared divided by 2 u squared, u is 24, so 24 squared cosine squared theta. This is equals to 10. Okay, let's simplify this equation. So 1 over cosine squared, we can write that as secant squared, and 10 times 35 squared divided by 2 times 24 squared. We get let's see if I copy everything down correctly. Yep, and we get 6125 over 576 secant squared theta equals to 10. Okay, so let's multiply everything by 576. Or should we just divide everything by 576, 576? Okay, never mind, let's just multiply everything by 576. So we get 20160 tangent theta minus 6125 secant squared. We can use 1 plus tangent squared equals to secant squared. And now we only have an equation in tangent theta. This is equals to 5760. Okay, all right, so now we get 20160 tangent theta minus 6125 minus 6125 tangent theta, and tangent square theta equals to 5760. So let's move everything to the right hand side. So we get 6125 tangent square theta and minus 20160 tangent theta and plus 5760 plus 6125, we get 11885 equals to 0. Okay, we can probably simplify the coefficients further. Let's try dividing them by 5. Okay. Yeah, let's divide all of them by 5. So 1225 tangent square theta minus 0160 divided by 5 minus 4032 tangent theta plus 1185 divided by 5. Yeah, 2377 equals to 0. Okay, let's see if we can simplify these further. Okay, we cannot. Yep. Oh, 7. Okay. Okay, not 7. 11. No. Okay, let's just leave it like this. So you can use a quadratic formula or you can try to factorize it. So I'm going to try factorizing this. Oh, okay. So yeah, we have to use our quadratic formula. So tangent theta is minus b, which is 403, 2 plus minus b squared, 4032 squared, minus 4 times 1225 times c, 2377, divided by 2 times 1225. So this one we'll get, okay, let me do it again. 032, 2377. Okay, you'll get 2.52205, and the other value will be 0.76938. Both the 5 decimal place. Now we can find the respective values of theta, just taking the inverse. And for this, I recommend that you take your value of theta in degrees because the angle is in degrees. So make sure to do that. 2.52205. I got 68.4 degrees. So, or you can just leave it like this, 1 degree for theta. Okay, you know what? Let this be 3SF. And then theta is going to be 0.76938, which is 37.6 to 3SF. And the reason they're 3SF is because these are values of theta. We're not expressing it in terms of degrees. So these are our final answers for this first part. Let's head on to the next part. Okay, so for the second part, we're told that given that P curves the wall, we have to find the minimum distance from point O where P can land. Okay, so we know our vertical displacement, this is y equals to 0, and we don't know our horizontal displacement. That's the minimum distance which we have to find. Okay, so all right, let's use the equation of the trajectory again. Okay, so y equals to x tangent theta minus gx squared, just n x squared over 2v squared, that's 2u squared cos squared theta. Okay, so let's simplify this equation a bit more. X tangent theta is 5 x squared over u squared, 1 over cos squared and secant squared theta. Okay, then u squared is 24. Okay, so 5 divided by 24 squared. Okay, y equals to x tangent theta minus 5 over 5, 76 x squared secant squared theta. Okay, now let's substitute y equals to 0. Okay, so we get x tangent theta minus 576 x squared secant squared theta equals to 0. So we get x tangent theta equals to 5 over 576 x squared secant squared replaces 1 plus tangent squared theta. Yeah. Okay. Let's divide both sides by x because we know that one of the solutions is obviously x equals to 0, which is not possible. So now we have tangent theta equals to 5 over 576. Okay, let's just keep this as secant squared theta. Yeah, x secant squared theta. Now let's make x a subject. So this would be 576 divided by 5 tangent theta cosine squared theta. Okay, so now we're gonna now take the value of theta. So let's take both. So first we'll take tangent inverse 2205. So 576 times 2.52205, 2.52205 times cosine square tangent inverse 2.52205. Okay, yeah, so this in your calculator 52205 cos tangent inverse 2.52205 cos squared, so be 39.5 meters to 3SF. Okay, now let's find our other x value for the other value. Okay, so this tangent theta 0.76938. This is 576 0.76938. 0.76938 cos squared tangent inverse 0.76938. So tangent 0.76938. All right. So it's 576 divided by 5 times tangent answer times cosine theta squared. Okay, so this one got a bigger answer, 55.7 meters to 3SF. So we're going to reject this answer, and hence our final answer is x equals to 39.5 meters to 3SF. So this is our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that a rough horizontal disk center O. So rough means that there's friction acting on the particle, rotates with a constant angular speed omega radians per second. So we'll let this be omega. And then a particle P of mass 1.6 kg lies on the disk at a distance 1.5 meters from O. Okay, so the weight of this, we can tell it's, 1.6 g. All right. And it's attached to point A vertically above O by a light elastic string. So this AP is a light elastic string. And we're told that this string has a natural length 2 meters, modulus of velocity 32 newtons, and makes an angle alpha with the vertical OA. So it's given in diagram here. Okay, particle P moves in a horizontal circle, also a constant angular speed omega radians per second. And we're told that particle P is on the point of slipping in the direction OP. So that means it's about to slip over here, so the friction must be acting towards O. Okay. And the coefficient of friction between particle and disk is 0.5. Okay, so for the first part, we're told that given that the tension in the string is 8 newtons, we have to show that sine alpha is equal to 0.6. Okay, so to first find sine alpha, we have to know the length of the string AP. So since it's an elastic string, we have to use the formula, like we have to know its extension in order to know its length. So this is the formula that we're going to use, T equals to lambda x over L. So let's write it down. And where RT is equals to 8 newtons, so the tension, and then lambda is 32 newtons, and then x is unknown, and then this divided by 2. Okay, so x would just be 8 divided by 16. So this is 0.5 meters. So hence we can say that AP is equals to 2 plus 0.5, which is equals to 2.5 meters. Yeah, so this is 2.5 meters. And since we're given the radius 1.5 meters, we can use simple trigonometry because this is just a right angle triangle. Okay, so this would just be sine alpha equals to opposite, which is the radius 1.5 divided by AP 2.5. And we just type into your calculator. It should give you 0.6. So shown. So this is our final answer for this first part. Let's head on to the next part. Okay, so now we have to find the number of revolutions per minute made by the disk and the particle P. Okay, so what do they mean by number of revolutions? So one revolution is 2 pi radians. Okay, and we know we're given the angular speed. Okay, right? So the angular speed measures how many radians it covers in 1 second. Okay, so so we can actually just what do I want to say again? Oh, we can find the number of revolutions per second first, and then we can multiply by 60 to get the number of revolutions per minute. So this is just going to be 2 pi divided by omega. So this gives us the number of revolutions per second, and then multiply by 60 to get the final answer. Okay, so first we have to find out omega. So to do that, let's label all of our forces in here. Okay, so we have a tension here, T, and then okay, we have our normal contact force. So label this R. Yeah, that's all. There's not other forces. Okay, we don't have to be concerned about that. Do we? Okay, all right. Okay, we do. So as we know, for circular motion, the vertical forces, they must be in equilibrium. So we're going to make an equation concerning the vertical forces first. So we have R and then the vertical component of T, which is T cosine alpha. So this is going to be T cosine alpha plus R equals to 1.6 G. Okay, and then you know that T is 8, and then cosine alpha, we can use our triangle. So this is alpha, and alpha is just 0.6. So 15 over 25, that is 3 over 5. 3 over 5. So this is going to be 25 minus 9. This is going to be 4. Yeah, so cosine alpha is just 4 over 5. Then plus R equals to 1.6 times 10, that's 16. So R would just be 16 minus 32 over 5. So this would give us 48 over 5 newtons. Okay, now using this, we can find out F using F equals to mu R. So mu is 0.5, and R is 48 over 5, okay, which is 24 divided by 5 newtons. Yeah, okay, now we can find our centripetal force, which just consists of the frictional force as well as the horizontal component of the tension, which is T sine alpha. So F plus T sine alpha, that would be equals to M R omega squared. So F is 24 over 5 plus T, that's 8, and then sine alpha is 0.6. Let me see, yeah, the sine alpha is 0.6, and then M is the mass, 1.6, and R is the radius, 1.5, yeah, and then omega squared. So now we can easily solve for omega. So let's simplify everything. So we have 48 over 5 equals to 1.6 times 1.5, which is 12 divided by 5 omega squared. So omega squared, 5 times 5, okay, 48 divided by 12, we get 4. Hence omega is just 2 radians per second. Okay, now let's just use this formula that we derived. So it's going to be 2 pi times omega. So pi revolutions per second times 60 seconds, you would get 60 pi revolutions. Or if you want to leave it to 3SF, also we can do this. Okay, so that's just 188 revolutions. So this is a final answer for this part of distributed 3SF. Let's head on to the next question. Okay, sorry everyone, the formula I used was incorrect. It's actually omega divided by 2 pi. This would give you the number of revolutions per second, and then multiply by 60. So hence, okay, let me just erase this. Yeah, this would just be 2 divided by 2 pi times 60. You would get 60 divided by pi revolutions. Or you can write this as 60 divided by pi, 19.1 for 3SF. Yeah, so this is our final answer for this part. Let's head on to the next question. Okay, so for this question, we're told that an object is formed by removing a solid hemisphere radius 2r from a uniform solid cone radius 3r and semi-vertical angle theta, where tangent theta is half. The axes of symmetry of the cone hemisphere coincide. The base of the cone are the same plane, so the bases are the same plane as each other. So all this is shown in the diagram above. Okay, so for the first part, we have to find in terms of r the distance of the center of mass of the object from its base. So we have to find this distance in here. So we'll let this distance be x bar first. Okay, not x bar, sorry, y bar, because it's a vertical displacement distance. Okay, so to first find the center of mass of a 3D object, we're first going to make a table. Okay, so this first column, we would fill out the volume. Okay, the volume and the centers of mass. Yeah, so let's do it for the cone and then the hemisphere first, and then we'll do it for the object. So the volume of the cone, can use the formula 1/3 height pi r squared. So the height, we're not given the height, but use the simple trig. So the height is just 3r. So tangent theta is opposite 3r over h. So h is just 3r over tangent theta, and tangent theta is half, so 1 over tangent theta is 2, so it's just 6r. So 1/3 6r pi r squared. R squared is times 3r squared. So this is 2r. Okay, so 2r times 9r squared, 18r cubed, pi r cubed. Yeah, so this is the volume of the cone. Now we need to find for the hemisphere. Okay, so the hemisphere, just half the volume of a sphere, which is 4/3 pi r cubed. But I'm sure all these formulas are given in your MF19. Yep. So if you forget, you can always refer back to there. So this is 2/3 pi r cubed. So 2/3 pi r is 2r cubed. And this is 16 over 3 pi r cubed. Okay, so 16 over 3 pi r cubed. And then the object is just these volumes subtracted. So this is 38 over 3 pi r cubed. So the center of mass for the object will be y bar. Okay, so for the cone and the hemisphere, for both, we're going to find the distance of their centers of mass from the base. Okay, so for the cone, center of mass, all the formulas given. Yeah, so right here, so solid cone pyramid, the center of mass is 3/4 h from the vertex. So that means from the base it is 1/4 times h. Okay, so 1/4 h, that is 1/4 times 6r, which is 3 over 2r. Yeah, and then for the hemisphere, solid hemisphere for radius r, it is 3 over 8r from the center. Okay, so yeah, somewhere here, 3 over 8r. So r is 2r, so this is 3 over 4r. Okay, now we're gonna make an equation in terms of moments. So to do that, just multiply the volume of the center of mass for the object, and do the same for the cone and hemisphere and subtract them. So this is 18 pi r cubed, 3 over 2r, minus 16 over 3 pi r cubed, 3 over 4r. So this is 3 over 3 pi r cubed y bar. Okay, we'll just simplify this as we go along. So 18 times 3 over 2, that's 27 pi r4. And this is 16 over 3 over 4, that's 4. So 27 minus 4, we get 23 pi r4. Okay, now cancel pi r cubed. Okay, so this is just r. Yep, and then can make r y bar the subject. So y bar is 23r times 3 over 38. So this is 69 over 38r. Okay, let me check. All right. Yeah. Okay. Yeah. Okay, so this is our final answer for this first part. Let's head on to the second part. Okay, so for this part, what's going on? Okay, so for this part, we're told that the object is placed such that its circular base makes contact with a rough plane, which is inclined to the horizontal at an angle alpha, and the object is on the point of toppling. The plane is sufficiently rough to prevent sliding. So it's just sitting right there. So we have to find the value of alpha. Okay, so let's draw a sketch of this first. So this is alpha, and then this is our cone. Okay. Yeah, so this is the cone, and then this is the center of mass. So if this is center of mass, then obviously the weight would be acting through here because when an object is on the point of toppling, the line of action through which the weight of the object acts, it must pass through the edge of an object. So this is the weight. Okay, right. So we know the distance of this. This is just y bar, and this one is from the center to the edge. Yeah, it's just 3r. And this one, this angle here is alpha. Yeah, so we can make a simple trigonometric equation. Tangent alpha is equal to opposite, which is 3r over y bar. Okay, so this is 3 divided by y bar. So y bar is 69 over 38 r. Yeah, so 3 divided by 69 over 38, get 38 over 23. Yeah, and then now we can easily find alpha, which is just tangent inverse of 38 over 23, which is equal to 58.8 degrees to 1 decimal place. Yeah, so this is our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that one end of a light elastic string of natural length 0.5 meters and modulus of elasticity 40 newtons is attached to a fixed point A on a smooth plane. We're also told that the plane makes an angle alpha to the horizontal, where tangent alpha equals to 7 over 24. And then we are also told that a particle P of mass 2 kg is attached to the other end of the string. The string lies along a line of greatest slope of the plane. So the string is parallel to the plane that it's on. And we're also told the plane P is initially held on the plane above the level of A. So P is above, like P is higher than the point A, where AP is equals to 0.8 meters. The particle P is then released from rest. And using all this information, we have to find the maximum velocity of P during the subsequent motion. Okay, so in order to do this, we're going to first draw a diagram. Okay, so alpha will be here. And we'll let point A be here. And we'll let P be at the very top. Yeah, so this is point P. I mean, this is the particle P. So the length from AP is 0.8 meters. Okay, and the natural length is 0.5 meters. So obviously there's tension in this string, okay? And since particle P has mass, its weight would be 2g. Okay? Yeah. All right. So to find the maximum velocity of P, we are going to use an energy method. So let's first find the initial energy. So initially, since P is higher than A, we can take the GPE of P with respect to A. So we'll use the MGH formula. So M is 2, then G is 10, and then H is 0.8 sine alpha. So this is just 2 times 10 times 0.8, and sine alpha, you can just use your calculator, 10 to the inverse 7 over 24, and then you take the sine, you'll get 7 over 25. So this is equals to 112 over 25 joules. Okay, and now we're gonna find the elastic potential energy. So to find this out, we'll use the formula given in our MF19, E equals lambda x squared over 2L. So let's write that down. So lambda is the modulus of elasticity, and then x is the extension, so 0.8 minus 0.5, which is 0.3 squared over 2L. So L is the natural length. Taking all this into account, we get 63 over 50 joules. So this is all our initial energies. And since it's released from rest, there's no KE. All right, so now we're gonna find a final energy when P is experiencing maximum velocity. Okay, so to do that, when P is at maximum velocity, P should not be experiencing any change in velocity, hence no acceleration, and it should not be experiencing any resultant force. So all the forces should be in equilibrium. So, and from an energy perspective, in order to maximize the KE, we're supposed to minimize the other energies as much as possible. However, for EPE, even if you go below like 0.5 meters, like X meters below A and X meters above A, the extension is still going to be the same, like even if it's above or below A. So what we can do is to minimize the GPE instead, and hence we're going to assume that P is going to be below A for this. So that means then tension would be acting here, and then P's weight is going to be here. So this T, and then this is 2G. All right, so by equating the horizontal component of 2G, which is 2G sine alpha to T, we can find T. So that's just 20 times 7 over 25, which is 28, sorry, oh my, 28 over 5 newtons. Yeah, so now we can find the extension of the string at that point using this formula, T equals to lambda x over L. So T equals to lambda x over L. X would be TL divided by lambda. So this is 28 times L, So L is the natural length over 5 times lambda, which is the modulus of elasticity. So this would be 14 divided by 14 divided by 5, which is 0.2. So this would be the extension of the string below A. All right, now we can find our GPE and EPE. So let's find the easy one first, EPE. So lambda is 14, and then x squared is 0.2 squared over 2L, which is 2 times 0.5. So this would just be 14 over 25 joules. All right, and now let's find our GPE. So here, since the GPE, we're taking relative to A and it is below A, it's going to be negative. So this is negative mgh. So m is 2, g is 10, and h is 0.7. Because 0.5 plus 0.2, you get 0.7 times sine alpha, which is 7 over 25. So this would give you minus 98 over 25 joules. Okay, and now using conservation of energy, we can equate the initial total energy to the final total energy. So we're gonna add the remaining energy with kinetic energy. So half mv squared plus 14 over 25 minus 98 over 25. That's equals to 1125 plus 63 over 50. So m is 2, and then v squared. Move all the constant terms to the right-hand side. That's 98 over 25 minus 14 over 25. You will get, sorry, oh my, just going. Sorry, give me a while. Okay, you'll get 19 over 10. And then v squared would be 19 over 10, taking the square root of both sides. You will get 3.02 meters per second to 3SF. So this is our final answer for this part. Let's head on to, for this question, let's head on to the next question. Okay, so here we're told that two uniform smooth spheres, A and B, of equal radii have masses 2m and m respectively. Sphere A is moving in a straight horizontal line with speed u, and sphere B stationary. Sphere A collides directly with B, and they both move in the same directions with speeds VA and VB respectively. After the collision, kinetic energy of B is 9.9 over 2 times the kinetic energy of A. Okay, so for the first part, we have to show this result is true. All right, so let's draw a rough diagram of what was going on. So let this be sphere A and this be sphere B. So A was initially moving speed u towards B in a straight line, and sphere B stationary, and then after that and B, they move in the same direction. So this is VA and this is VB. Yeah. Okay, so this is 2m, this is m, this is 2m, this is m. Okay, now let's use the conservation of principle of momentum. Okay, so the total momentum before 2mu plus m times 0, which is 0, equals to 2mvb plus mvb. So m cancels out. So this is the final equation that you will. Oh, sorry, this is supposed to be VA. So VA plus VB. So this is the first equation. Now let's make an equation with the second piece of information regarding the kinetic energy. Okay, so we're told the kinetic energy of B is 9 over 2 times the kinetic energy of A. So let's find an expression for the kinetic energy of A. So that's just half 2m VA squared. Yeah. And then this is times 9 over 2. This is equals to half mvb squared. So you would get 9 over 2 mva squared equals to half vb squared. So multiplying both sides by half, you get 9va squared equals to vb squared. Taking the square roots of both sides, you will finally get vb is equals to 3va. Okay. So to make this easier, we're going to make VA the subject. So VA will just be VB over 3. So this is the second equation. And substituting everything, you'll get 2U equals to 2 times VA, which is VB over 3 plus VB. So this is 2U equals to 2/3 plus 1, which is 5 over 3 VB. And making VB the subject, just multiply both sides by 3 over 5 times 2U. You'll get 6 over 5U. So this is our final answer. We've shown the result. Let's head on to the next part. Okay, so now we're told that sphere B then collides with a fixed vertical barrier. Immediately before the collision, the direction of motion of B makes an angle alpha with the barrier. Immediately after the collision, the direction of motion of B makes an angle beta with the barrier. And we're told the coefficient of restitution between B and the barrier is 4 over 5. As a result of the collision, the velocity of B is reduced to 12 over 25 square root 5u. Okay, so for this part, we have to find the value of sine alpha plus beta. Okay, so to do this, we first have to know what sine alpha and cosine beta and cosine alpha and sine beta mean. Then we can apply it in the addition formula. So we have to find those first. Okay, so let's make a diagram of everything that happened. So we'll let this be sphere B. So it says before the collision, direction of motion of B. So this makes an angle alpha with the barrier. And then after the collision, direction of motion of B makes an angle beta with the barrier. So this is an angle beta. Okay. So one thing you would have to know is that the vertical component of the velocity of sphere B does not change before or after the collision. So we can equate that first. So, okay, we'll let this be V and we'll let this be W. Okay, this would be VB. This would be W. Okay, so first VB sine alpha would be equals to Wait, no, sorry, cosine alpha would be equals to W uh, cosine beta. Okay, so this is the first equation. Okay. And then now the second equation, we're going to use the coefficient of restitution. So the formula for the coefficient of restitution is the relative speed of separation over the relative speed of approach equals to 4 over 5. So the speed of separation is the horizontal speed after the collision. So in that case, this would just be W sine beta over the speed of approach, which is also horizontal, which is VB sine alpha equals to 4 over 5. Okay, now we're going to make W sine beta the subject. So this is just going to be 4 over 5 VB sine alpha. Okay, so this is our equation 2. Okay. Oh, I just realized we're given W. So, okay, never mind. We'll just substitute it later. So to make this easier, let's square both equations. So the first equation would just be VB squared cosine alpha squared equals to W squared cosine beta squared. And then the second equation would be W squared sine beta squared equals to 4 over 5 squared, that is 16 over 25. VB squared sine alpha squared. So this is, okay, this is the third equation, this is the fourth equation. Okay, so to make this into equation in one variable, we're going to use our trig identities. So we'll use the cosine square alpha plus sine square alpha equals to 1. And we will substitute it. So VB squared cosine square alpha, we can equate it to W squared times 1 minus sine square beta. Yeah. Then expanding it, we get VB squared cosine alpha squared equals to W squared minus W squared sine square beta. And then we can use the fourth equation to substitute. So this is VB squared cosine square alpha equals to W squared minus 16 over 25. VB squared uh, sine square alpha. Okay. So to make this an equation in one variable, oh, sorry, this is the V squared, okay. So it'd be VB squared cosine square, we can replace with 1 minus this sine square alpha equals to W square minus 16 over 25 VB square sine square alpha. So this would be our final equation in one single variable. Okay.
Now we're going to move everything to the left-hand side. So this is 1 minus 16 over 25. You'll get 9 over 25 VB square sine square alpha equals to VB squared. We'll move the W squared to the other side, equals to W squared. Okay, right now we can substitute our values for VB and W squared from the initial value. So 9 over 25 VB, that's 6 over 5U squared sine squared alpha is equals to 6 over 5U squared minus W. So W is just 12 over 25 squared 5U. 12 over 25 square root 5U squared. Okay, so I'm just gonna straight away simplify this. So 6 over 5 squared, you will get 324 over 625 U squared sine square alpha equals to 36 over 25 U squared minus 12 over 25 square root 5 whole thing squared is 144 over 125 U squared. So, sorry, 324 over 625 U squared sine squared alpha. This is equals to 36 over 25 minus 144 over 125. You will get 36 over 125 U squared. So we can cancel out the U squared and just directly find sine square alpha. So that's 336 over 125 divided by 324 over 625. So you will get 5 over 9. And you can take the square root of both sides. You will get plus or minus 5 over 9 square root. And since alpha is obviously a cubed, we're only going to take the positive square root. So final answer is squared 5 over 3. Okay, now we're going to also have to find cosine alpha. Yeah. Okay. Oh, you know what? Let's find sine beta first using our second equation. So sine beta is equals to 4 over 5 VB sine alpha times 1 over W, which is equals to 4 over 5 times VB. So VB is just 6 over 5U. Then sine alpha is, oh wait, is square root 5 over 3. And then 1 over U, that is 25 over 12 squared 5. 25 over 12 square root 5. Okay, so just type all this into your calculator, excluding the U. Get 2/3 U. Oh wait, the U's are supposed to cancel out, so you just get 2/3 for sine beta. Okay, now we can just find cosine alpha and cosine beta using the right angle triangle. So alpha sine alpha, that's opposite, which is square root 5, and the hypotenuse, which is 3. Using Pythagoras theorem, 9 minus 5, 4. So square root 4, that's 2. And then for beta, sine beta is 2 over 3, so opposite is 2. Hypotenuse is 3. So Pythagoras theorem, 9 minus 4, 5. You'll get square root 5. Okay, so hence cosine alpha is 2 over 3 and cosine beta is equals to square root 5 over 3. Okay, and now we can finally find sine alpha plus beta using the addition formula for sine. It's given in your formula sheet right here. So it's sine A cosine B plus cosine A sine B. So we'll take sine alpha first. So sine alpha square root 5 times over 3 times cosine beta, which is also this, plus cosine alpha 2 over 3 times sine beta. So we're putting all this together, you will get 1. So this is our final answer for this second part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that a fixed hollow sphere has radius A and center O. The points A, B, C lie on the inner surface of the sphere with OA and BC horizontal. Yeah, so you can see they gave all this information in the diagram as well. A portion of the sphere has been removed by horizontal cut through points B and C at a vertical distance Ka above the center of the sphere. So this is where it has been cut through. Okay, and then where K is a positive constant, K is less than 1. So K is a rational number. And the points O, A, B, and C all lie in the same vertical plane. OB makes an angle theta with the upward vertical through O. Yeah, so all this is given in the diagram. Okay, this is the important part. A particle P of mass m is free to move on the smooth inner surface of the sphere. The particle P is projected vertically downwards from A with speed u and begins to move in a vertical circle. Okay, so for the first part, we're supposed to consider the case where u equals to square root 6 over 5 GA. The reaction on P at B is half the reaction on P at A. So we have to find the value of K. Okay, so first of all, let's consider the energy at each of these positions. So we're going to use our conservation of energy law and equate the total energy at these places. So at A, we're going to take the GPE relative to A. Okay? So obviously at A, there's no GPE. Okay? There's only KE. So that's just going to be half mu squared. And that's equals to the energy at B. So at B, it's still moving. Let's say the speed is V. And it's definitely above A. So there is GPE. So we can see it's Ka above A. So this is just going to be mgh, which is Ka plus half mv squared. Half mv squared. Okay, so yeah, this is our first equation. Okay. Yeah, this is the first equation using energy. Now we're going to make an equation in terms of forces. We're going to consider the forces acting on them. Yeah, so obviously we have, so at A, we have the weight mg as well as the reaction force, which acts perpendicular to the velocity of A at that point. So we will call this N. Okay, let's just label the forces, okay? And then same for B, there is the weight acting downwards and the reaction force, which acts perpendicular to V. So as you can see, for both of them, the reaction force is acting towards the center of the circle, so they definitely be part of the centripetal force. Okay, and we're now going to use this information right here. Okay, so we'll let the reaction at B be N. So here the reaction must be 2N using this information. Okay. Yeah, so let's take this motion into account. Okay, so at A, we're going to use the formula F equals to mv squared over r. So F is the centripetal force acting. So there's only one force acting in the center, which is the reaction force. So this is 2N equals to m u squared over r. R is the radius, which is A. This told us in the question. All right. So this is okay. So this is 2N A equals to m times u squared. So this is our second equation. Now let's do it for B. So for B, it's slightly more complex because mg is acting vertically downwards, but B is not going vertically downwards. So for mg, we have to take both the horizontal and vertical components relative to the plane, to the direction of the movement of B. So if you realize the horizontal component of the weight, which I'm going to write as, okay, what's the angle? Okay. As mg cosine theta. Okay, so mg cosine theta, this would be the component. So this is going to be n plus mg cosine theta. This would be equals to, mg cosine n, wait, sorry, n mv squared over a. So this is n a plus mga cosine theta equals to mv squared. And to find cosine theta, we can make use of the Ka and the radius a. So, sorry. So from the diagram, we have a right angle triangle with hypotenuse A and height Ka. And our angle theta is here. So cosine theta from here be the adjacent side, which is Ka over the hypotenuse, which is going to give us K. So this is Na times mg Ka equals to mv squared. So this is the third equation. Okay. All right. What else do we have? Oh, okay. To make this simpler, we're going to substitute NA equals to mu squared over 2. So mu squared over 2 plus mgka, that's equals to mv squared. And now we can substitute it into our first equation. So half mu squared equals to mgka plus half times mu squared over 2 plus mgka. So half mu squared equals to half mgka plus mgka. That's 3 over 2 mgka plus 1 over 4 mu squared. Okay, let's make mgka the subject. 3 over 2 mgka is equals to half mu squared minus 1 over 4 mu squared. You'll get 1 over 4 mu squared. Okay. Now we're going to substitute u equals to square root of 6 over 5ga. So we get 3 over 2. Okay, we'll just make it kmga equals to 1 over 4 and 6 over 5ga. Okay, so now we can cancel mga from both sides of the equation. And k will just be 1 over 4 times 6 over 5 times 2/3. And this would give us 1 over 5 as our final answer. So this is our final answer for the first part. Let's head on to the second part. Okay, so for this second part, we're told to find an expression for u in terms of a and g in the case that the particle just reaches b. Okay, so when the particle just reaches b, the reaction force at b would be equal to 0. So n is equals to 0. Yeah. So it okay, which formula should we use? Equals to 0. Oh. Hmm. Oh wait. Okay, yeah, so when the particle just reaches B, V will also be equal to 0. So we're going to use that. So we'll use our energy equation. Okay, so half mu squared equals to mgka. So K is 1 over 5 mga. And then half mv squared would obviously be 0. Okay, so m's cancel out. Then u squared is 2 over 5 ga. And hence u is just square root 2 over 5 ga. So this is our final answer for this part. Let's head on to the final part. Okay, so now we're supposed to find an expression for u in terms of a and g in the case that the particle passes through B and in its subsequent motion reaches C. Okay, so let's visualize the situation that they're describing here using our diagram. So we're told that the particle should start from A, should pass through B, and should go beyond B, and should stop at here. So you have to understand that from B onwards, the particle would no longer be in contact with the sphere, and it will free fall fully under gravity. So this would result in projectile motion all the way until C, because only gravity would be playing a part in its motion. Okay, so in order to do that, we should know what our V is, okay? Find an expression for U. Okay, so we should know what our V is and the angle at which is projected from B. So the angle which it's projected at, since this is a right angle, this is 90 minus theta, B would be projected at theta degrees at V meters per second. All right. Okay, now we're gonna find out the distance from B to C. Then we can know the horizontal distance that the particle has to travel from B to C. So, all right, what should we use? Okay, let me see what to use. Oh, okay. So how about, oh, we can just use Pythagoras theorem. Like the length of this side would be half of the distance from B to C. Like distance from B to C is here, and then half of this is part of this right angle triangle here. So we're gonna find this distance first. Or let's just find BC directly. So BC is just gonna be 2 times the distance of that, which is square root a squared minus ka squared. So a squared minus k squared, a squared. So simplifying, you'll get 2a 1 minus k squared. Yeah. So this is the length of BC. Okay. So now we have the horizontal distance. Okay. Now we're going to use our equation of the trajectory to find out. So this is our equation of trajectory, y equals to x tangent theta minus gx squared over 2v squared cosine theta. Yeah, so let's copy it down. Y equals to x tangent theta minus gx squared over 2v squared cosine squared theta. Okay. All right, let's substitute y equals to 0 and x equals to this. So x is 2a square root 1 minus k squared tangent theta. That would be opposite over ka. So this is 1a 1 minus k squared. So tangent theta would just be opposite a times 1 minus k squared square root over ka. So a's cancel out, so you just get this. So let's substitute that. Okay, so 1 minus k squared over k minus g 2a square root 1 minus k squared, whole thing squared, over 2v squared cosine theta is k, so cosine squared theta is k squared. Yeah, so this would result in 0. Okay, now let's simplify all the k's. So 1 minus k squared, 1 over 5 squared, divided by 1 over 5, 24 over 5 times 2, 48 over 5a equals to g 2a, wait, no, 2a times square root 1 minus k squared. That is the whole thing squared. You get a squared times 2 times 1 minus 1 over 5 square you get 96 over 25 over 2 v square 2k square 2 over 25. Yeah, so substituting k, that was completely unnecessary. You could have just directly substituted the value of k. Yeah. All right. So a's cancel out. Okay, this would be 48 over 5 equals to 96 over 25 divided by 2 over 25. You get 48. So this is 48 GA over V squared. So V squared would therefore be 48 GA divided by V squared 48 divided by 5. So 48 divided by 48 over 5, you get 5 GA. So this is the value for V squared. All right, now we can find our U. Okay, using our energy equation. Okay, so half mu squared is equals to mgka. So 1 over mga plus half mv squared, which is 5ga. So half mu squared would be equal to 5 over 2 mga plus 1 over 5 mga. That's 27 over 10 mga. Cancel out the m's, and then you get u squared is equals to 27 over 5 ga. And then u would just be the square root of 27 over 5 ga. So this is our final answer for this part, as well as the entire question. And we have come to the end of this paper. So I hope you found this video helpful, and if you did, please make sure to like and subscribe for more future past paper solving videos for A-level maths and further maths. And if you have any queries or doubts or future video ideas, please feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.